Hello everybody and welcome to this video in which we are going to be doing our deeper dive into what's really happening with string and integer data types in Python. Okay, so this is our big idea that actually computers don't know what text or numbers are. They only understand, well, electrical pulses on a wire, right? They are electronic calculating machines. So what I mean by that is voltage, electricity, on the wire. So that could be high voltage and that can be low voltage. So high voltage might be, let's say, 5 volts, and then low voltage, no volts. And the transistors inside the hardware, the little switches, right, the electronic switches, they're going to be saying, okay, let the electricity through or block it. So it's on or off, right, on or off. And ultimately, our instructions, which we write in various coding languages, ultimately are going to break right down into binary, so ones and zeros, which are then fed into the computer. So then the 1 will be high voltage, 0 will be low voltage, right? And that's kind of how we give our instructions to the computer. Now, let's have a look at what's going on with integer. Well, an integer is a whole number, as we know already. And it's stored, okay, as this binary representation here. Now let's just take a quick look at binary, right? Now you might know this, you might not. So that's why I've got this here to kind of go over it. Now we are familiar, of course, with base 10, with decimal system. Now if you think about decimal system, you would have like here in the ones column, this is the ones column, you would have 1, 1, and then you could have 1, 1. And then you could say, okay, I've got 2 ones, and I've got 3 ones, 4 ones, 5 ones, 6 ones, 7 ones, 8 ones, 9 ones. And then when you get a group of 10, you would go to the next column, right, which would be here. This would actually be tens. And you would say, okay, so I've got one group of 10 now, and I've got 0 ones. So this, we are familiar with this, right? In decimal, in base 10, when we see this, we just say, okay, it's 10. See, it's 10. But what's it really saying? It's saying I've got one group of 10 and I've got no ones, right? That's what it's really saying. I've got one group of 10, no ones. Okay, so let's come back to binary. You see, this is no longer the tens column, it's the twos column. Simple as that, it's the twos column. So this in binary, 1, 0 in binary is saying I've got one group of 2 and then I've got no extra ones. So I've got 2. That's how we write 2 in binary, 1, 0. It looks weird when you first look at it, but once you understand what's happening, it's really, really simple. Oh, I've got one group of 2 and I've got no ones, that's therefore 2. In binary, that's how we do it, okay? So let's just go back a step and say, okay, how do I write 1 in binary? Well, I've got 1, 1. Okay, and then as soon as you've got a second one, you bundle them together and you say, okay, I've now got one group of 2 and I've got no extra ones. Okay, question, how would I write 3 in binary? Answer, well, 3 is, of course, one group of 2 and then an extra 1. So like that. We've got 1, 2 and then 1, 1. So it's that. You're looking at it saying that's 11. Yeah, if you're seeing decimal, one group of 10 and then 1, 1 is 11. But in binary, it's one group of 2 and then 1, 1, so that's 3. Okay, fine. And let's just come back slightly. So how about 4? Well, when we get this in binary, we're saying, okay, actually, I've got its base 2. It's getting twice as big. Decimal, it gets 10 times as big each time you go one space left. Binary gets 2 times as big. So it's doubling each time you go one space left. So I've got, okay, one group of 4. Oh, sorry. Got one group of 4. I've got no extra 2s. I've got no extra 1s. Therefore, 1, 0, 0 is how we write 4 in binary. Of course, it looks like 100 if you're seeing it decimal. But think about what's happening. That's saying I've got one group of 100. I've got no 10s. And I've got no 1s. Just 100. Okay. However, in binary, you're saying I've got one group of 4, I've got no 2s, and I've got no 1s, therefore I've got 4. Okay. So bearing this all in mind, let's come back to the example in our technique card, the deep dive technique card, which is 10. Well, in binary, that's saying 10 is actually one group of 8. We have got no 4s. We do have another 2 though, don't we? 8 add 2 is 10. Sorry, we do have it. 8 add 2 is 10. Right? But we don't have an extra 1. Right, so if you look at that, it's saying I've got one group of 8, I've got no 4s, I've got one group of 2 and no 1s, and 8 add 2 is 10. So in binary, 1, 0, 1, 0 is 10. That's how we represent 10. Okay, I've got one group of 8, no 4s, one group of 2 and no 1s, and 8 add 2 of course is 10. So that's how we write 10 in binary. So Don't worry too much about all this here, right? That's bit patterns and bytes and such. Don't need to go into that because I want to keep the video short. But that's the basics of binary. Coming back to this then, in the computer, I want this here, 1010, it's saying, okay, that's a number, that's the integer. Coming down to strings, what are strings? Well, they are character codes. What are character codes? Okay, ASCII or Unicode. Think about ASCII to start with. If you want to find out more about ASCII, you can just kind of search for it, right? ASCII codes. A good one is Doug3 Schools. That's got lots of great reference points for anything really to do with computing. Have a look at that. I'm not going to go over it. You can do that in your own time. But essentially, if you look at it, a string is a string. What's it a string of? It's a string of character codes. It's a string of character codes. So this capital A, we can represent in ASCII as 65. And then the L, the lowercase l, can be 108, and the E 101, and the lowercase x 120, which of course, because these are now numbers, 65, 108, 101, okay, we can represent in binary. Okay, so if we go back to that capital A, 65, in binary, that's this here. One group of 64, and then one group of 1. 64 is here, you see. One group of, can I get back into that? I should be able to. Yeah, let's just do that. So to write 65, we're saying, okay, I've got one group of 64, no 32s, no 16s, no 8s, no 4s, no 2s, but I do have that extra one, because 64 plus 1 is 65. 1, 0, 0, 0, 0, 0, 1 is 65. And that's the character code for the capital A. But then, of course, it's a string, so we've got all of these other character codes here. So essentially, Python is saying, okay, this is a string of character codes, right, like that, and that's how it's stored in memory, compared to here, where we've just got this stored here, because that's just the integer there, that's the number 10. Okay, so why can't we add these? Because Python just doesn't know how to, I suppose, concatenate. It just doesn't know how to concatenate that string of character codes and the integer, the number. It just doesn't work, and that's why we have to either convert the number into text using the string function, or preferably use the f-string like that, and we go over that in our main video on how, on string and integer data types. Okay, type, I didn't actually go over that before. Type is a useful function. You can just check the data type of whatever you pass here as the argument to the type function. Okay, you can play back with that, try that, and it will just return, okay, what data type it is. Very, very useful when you're debugging larger projects. Okay, and then there's a few things for you to have a read over here, which I'm not really going to go over. Don't think I need to. The main thing was just to go over, I guess, binary a little bit and show you what's working with integer and string data types. Hope that was useful. Hope you enjoyed it. Hopefully see you in the next video. Until then, take care.